Hey guys, I think this is working kind of a trial run, and I'm hoping you guys are watching here video. We're going to start into chapter one, but one thing we always do in my classes is we always do jokes. So we got to start out with jokes. So here we go. I'll do better jokes on actual class days that you guys are here, but here we go. Why do only small elves live under toadstools? Because there is not much room. And then the other one, where do pianists go for vacation? The Florida Keys. But guys, welcome to AP Chem. And I mentioned this some this week when I was meeting with you guys, but you've already won my admiration by just being willing to sign up for a class like this. And it's going to be a hard class, a challenging class. I hope you find it a fulfilling and a rewarding class. I do think it'll prepare you for school beyond, get myself here center, beyond our class, be it next year if you're a junior in classes you're going to do here at Highland Dretch High School or beyond. But you're going to need to be watching our videos as long as we're doing the hybrid. Or if we're doing remote, you need to be watching these videos. And as long as you're not sick, I need you coming to class. So anyways, welcome to AP Chem. And we're going to start off in chapter one here. And I'm kind of going through this. This is the first time, so it's a trial run. And hopefully this is going to work. But I'm going to put up the notes, which I showed you guys the other day, how you guys could go to these notes. Okay, so here are the notes that you guys can find online. So let me go back. I was playing around with this, but okay, so here is the, and I haven't updated this for a while, and I mentioned this in class the other day, but here you can see, if you look, you can see the students that got a 5, 4, 3, and you can see how we did at our school and the averages. And you can see we typically on the AP test get grades, get percentages that the normal on the average, you can see that the normal pass rate is in the low 50s. So students that get 3, 4, or 5. We here at our school, 1 year 74, 1 year 82, 1 year 75, 1 year 77. So mid to high 70s or even 80s. Last year we didn't do as well, but last year was such a difficult year with the way it ended in the spring. So in defense of myself and the students I had last year, it was weird. We actually were right. I think we were a little below the average, so that was kind of disappointing. But bottom line, usually on the AP test, we usually do very well on the AP test. So hopefully that'll be the case with you guys. But my goal is that you simply learn a lot of chemistry, and hopefully you'll find it an enjoyable, fulfilling class. So you can look at that. And the way it kind of works, in my understanding, and different schools are different, but a 5, usually they're going to give you credit for that, just credit for at least a semester of general chemistry. 4, usually, depending on your major. 3, maybe not so much. And there's really 2 kinds of college chemistry classes. You're going to have some that are for science majors, and those are going to be they're going to be 10 credits for a year. You'll have 3 credits for lecture, where you'll meet 3 times a week, Monday, Wednesday, Friday for an hour, and then you'll have a 2 or 3 hour lab for another 2 credits. And again, depending on the school, how you do on the AP test, you can get us maybe a semester or a year of that out of the way. And then they have chemistry for non-science majors, which are usually not as many credit hours. If you're not a chemistry major, might be 4 credits where you have a shorter lab, 4 credits a semester. And I have many students, and some of you that are seniors that go do college visits for schools that are meeting in session. I've had many of my students come back and they said they've sat in a first-year chemistry class in college, and they go, man, this is exactly what we've been learning. So even though it's not in college, this is a college-bound class, and I'm going to treat it that way. So you can look at that. Bottom line, I want you to learn a lot of chemistry. Hopefully it'll be an enjoyable, fulfilling time, and hopefully we'll do well on the AP test at the end of the year. Okay, here are the problems from chapter 1. And like I said when I met with you guys this week, I am never going to collect the homework problems, but I will tell you when I make up the test, the problems really are going to come from a couple different places. One is going to be the problems, these I have on the screen right now. And like I showed you on the Canvas on my website, I have the answers on that one website, the answers to these problems. But I'll go from the textbook problems, from the problems we do in class, from the problems on the quiz, from the lab, and the review. And all those are going to kind of be sometimes almost exactly the same problem. Okay, and so those are the problems that I want you guys to do. And real quick, just talking about chemistry and the definition of chemistry, which I'll talk about with my first year chemistry students, is the study of matter and how it reacts. So I always think it's simply put, chemistry is the study of stuff and the changes it goes through. So what things are made up of, and then the reactions that it goes through. And I'm going to do some demos in class on Monday and Tuesday, and we'll look at, again, some of the stuff that you will remember from first year chem, but it could be the composition of a pencil or the air or my hair or what my car is made out of, and then the changes it goes through. So that's what chemistry is. It's called the central science because all the other sciences are better understood with a knowledge of chemistry. So the study of stuff and the changes it goes through. Okay, I'm going to real quick, these are things I'm never going to quiz you on or test you on, but I do want to go through these things just real quick. Careers as a chemist, and it can be definitely a rigorous thing, but there's a lot of different avenues if you want to go down this path eventually to get into a career. An analytical chemist measures the quantity of a substance present. Example, you could work for the DEA, the Drug Enforcement Agency, and measure the concentration of chemicals in ground or air. Another example could be kind of related to environmental chemistry and what is in the air or what is in the river or what is in the soil. So an analytical chemistry, we will definitely do analytical stuff in here. A chemical engineer, another career as a chemist. Design chemical factory for producing chemicals, like an example, a petroleum engineer designs refineries to convert crude oil to gasoline and other usable products. Can be gasolines, drugs, certainly with medical field. Kind of puts together chemistry and engineering. So it's another career as a chemist. A biochemist, pretty important with what's going on right now with the virus. So study of chemical processes within living organisms. So things to do with medicine, botany, genetics, nutrition, and cells. So if a cancer cell replicates quickly, an example of a biochemist, they develop a chemical that causes replicating cells to die. And I think that the medical researchers right now that are researching a vaccine or how to treat the COVID are certainly using biochemistry. Polymer chemist, study of multiple molecules. We really won't, depending on the timing, we may at the very end of the year do a little bit with organic chemistry, but and that would be connected to polymer chemistry. But the study of multiple molecules, plastics would be an example. And then the next one, environmental chemistry, environmental chemist, which is a big thing that could be definitely kind of growing right now, chemical and biological phenomena that occur in natural places, air, soil, and water, working on, cleaning up a former mine or something, cleaning up a river or something to do with the oceans, definitely a big thing there. So in the way, if you end up deciding to go into chemistry in college, kind of your first year is going to be what we do here in AP Chem, but just go a little bit further. They'll just call that probably basic inorganic chemistry. You'll have lecture and labs. Second year, you're going to do, again, 10 credits. It'll be organic chemistry which is kind of a separate field in chemistry, and that would be, again, another 10 credits, 5 first semester, 5 second semester. What I did in third year, I did a semester of physical chemistry, which took math, kind of calculus with chemistry, and then I did analytical chemistry, lecture and lab with that. And then my fourth year, I did biochemistry, which by the name biochemistry, you need to have organic chemistry. But again, I'm not going to quiz you on that or test you on that, but I did want to go over that with you. Okay, so quick review. Know the metric prefixes. So I'm going to go back here and come back to the screen now. Okay, I'm working on this. Okay, so one thing I showed in first year chem, that's something, just the metric prefixes for you guys to just quickly review and refresh yourself. And I always use this, and it's kind of like, it's maybe too simple, but it's a way to remember this. And it says the king hates dates because dates cost money. The king hates dates because dates cost money. And this is kilo. We never will use this. This is hecto. This is deca, which we'll never use, but this is the base. So this is kilo. This is the base, which means without a prefix, like a gram or a meter or a liter. This is deci, which we'll never use. We're never going to use this. We're never going to use this. We're never going to use this, but we could use this, centi. Centi, like a century, is 1/100th, and then milli, which is 1/1000th. Now, so kind of here are the key prefixes: kilo, the base, which of course isn't a prefix, centi, and milli. And a couple other ones that we could use in AP chemistry once in a while is capital M, which is mega, which is 1/1,000,000th. Let me go back here. A kilo would be 1,000 times as big. A kilo, a kilogram, a kilometer. A mega is 1,000,000 times as big. Base is just 1. A centi is 1/100th, and a milli is 1/1000th. Okay, so, but a mega is another one that we could use. Another one is micro, and micro comes up once in a while. It looks like a lowercase cursive u, micro, and it is 1/1,000,000th. So that prefix could come up occasionally. And then another one is a nano, lowercase n, nano is 1/1,000,000th. And so here, these are the really key metric prefixes. The kilo, of course, the base with no prefix. Centi, kilo is 1,000 times as big. A centi is 1/100th. The milli is 1/1000th. A mega, which will come up rarely, but once in a while, is 1,000,000 times as big. A micro is 1/1,000,000th, and a nano is 1/10,000th. Okay, so now I want to go back to the notes. Okay, so thanks for being patient with me here as I work on this. Okay, so this is where we were. Okay, so those know the metric prefixes, and that's what I was just talking about on the board. Okay, and then uncertainty. Every measured number is written to one uncertain digit. And you might want to note this. This is how I always do it. And there's two ways to look at this. So you can, whichever way makes more sense. You measure in a measurement, you measure all the numbers you're sure of, and the last reading is an estimated number. So this is one way to look at this when you're doing a measurement in terms of significant figures. All the numbers you're sure of plus the last number you write down is an estimated number. Now this is the second way. The second way is the way I do this, and it says whatever the measuring tool goes to, you measure one more decimal place. So whatever the measuring tool goes to, you go one more decimal place. Okay, so what I'm talking about is this. Okay, so again, whatever the measuring tool goes to, you go one more place. So I use the example, because I'm a sports person, of a football field. Okay, so a football field, okay, is we have the yard lines, okay, and then on a football field, so we've got, here's the 10-yard line, here's the 20-yard line, here's the 15-yard line, and we've got the little marks on the field, little hash marks. Well, wherever the ball is at, what I'm saying is whatever the measuring tool goes to, you go one more place. Well, in a football field, the measuring tools are ones, so we would go one more place. So in this case, we would say 18, I'm sure of that, 0.5, because this goes to the ones, I would want to go to the 10th. So whatever the measuring tool goes to, you go one additional place. And so that was definitely a very important thing in just in science in general. So uncertainty, every measured number is written to one uncertain digit. So the last number written down is an estimated number. Okay, so here is an example. So let's look at this measurement. It looks like on a graduated cylinder. So again, the way I look at this is whatever the measuring tool goes to, I want to go one additional place. In this case, we have the 80s and the 90s, so everything goes here to the ones. So I would want to go to the 10th. So in this reading, it would be, for letter A, I would have it as 85.5. For letter B, I would have it be 83.0. And so I want to go to the 10th. And for D, it would go to the 10th. So it'd be 90.0. Mr. Conyers just walked in here. Hi, Mr. Conyers. I'm doing a recording here for my class, for my AP chemistry class. No, it's okay.
Are you still recording?
I'm still recording.
Oh, then I'm not going to stick around.
Mr. Conyers is a good friend, and he's been a big help to me. So I just wanted to.
Talk to you later.
He'll see you guys around. Okay, now here on the second graduated cylinder. So again, now this time, 8 and 9, so every increment here is to the 10th. So that would mean we would want to go to the 100th. Again, whatever the measuring tool goes to, you go one additional place. So what I would have here for letter A is I would have, again, I want to go to the 100th. So I would say 8.55. I would not stop at the 10th. And if you said 8.56 or 8.54, it would have been okay. The key is you needed to go to the 100th. So for A, I have it as 8.55. The key is you go to the 100th. For B, I have 8.30, and that one's pretty clear. It's on 0, but the key is that I went to the 100th. Again, whatever the measuring tool goes to, here the measuring tool is going to the 10th. I want to go to the 100th. And for C, I would have it as 9.00, but it's important that I have both of those zeros. Again, because the measuring tool goes to the 10th, I want to go to the 100th. Okay, so take a second and look at this. So again, what is the measuring tool measures? What are these increments over here to the right? And I think they're to the hundredths. That means I would want to go to the 10th. So if I looked at A, I would have 8,550, okay? And again, that last number is estimated. And then to record that to 3 sig figs, because I want to go, if the measuring tool is going to the hundredths, I would want to go to the 10th. So I would say 8.55 times 10 to the third. And this is one of the reasons we're going to use scientific notation a lot. 8.55 times 10 to the third. For letter B, now again, I want to go to the tens because the instrument is going to the hundredths. So I would say I want to go, it's going to be 8,300, but to 3 sig figs to the tens, 8.30 times 10 to the third. And then for C, I'd have 9.00 times 10 to the third. So I'd want to go to the 10th. So whatever the measuring tool goes to, I want to go one additional place. Okay. Then back to more stuff with sig figs. And sig figs and zeros were what was tricky here. And The non-zeros, the easy non-zero digits are always significant. So 1 through 9, they are always significant. And then zeros were the tricky thing here. So zeros, captives or three kinds of zero. Leading zeros are not measured, and I'll do some examples here. But if you had 0.00014, those leading zeros are not significant. So 0.00014 would have two significant figures. So leading zeros are not, they're part of the number, but they're not significant. Captive zeros are significant. So if I had 101, that zero is a captive zero, like it says on B, that would be significant. And then trailing zeros are counted as significant only if there's a decimal. So if I had 100 without a decimal, then it would have one significant figure. But if I had 100 with a decimal, it would have three significant figures. So zeros. So leading zeros never significant. Captive zeros always significant. And then trailing zeros are significant if there's a decimal. Okay, exact numbers are definitions are integers. They have infinite sig figs. So if we say two things are equal, then those have infinite significant figures. So, okay, and then in calculation, and this is where it's going to come up a lot. Okay, so manipulating measure devices. When we multiply or divide, which is what we're going to do most of the time, our answer is rounded to the least number of significant figures in the problem. So when we multiply or divide, the answer is rounded to the least number of significant figures. When we add or subtract, it's a different rule. So instead of rounding to the right number of sig figs, we round to the decimal place. So whatever has the least decimal places is where we round if we add or subtract. Okay, so multiply or divide, the number of whichever has the fewest sig figs is where I round. And if I add or subtract, it would be the number that has the least decimal places. Okay, so some examples here. Okay, so let me go back to the board. So first of all, in terms of just counting significant figures. So here are some examples. So let's say we have, all I'm doing now is I'm counting significant figures. So if I've got this number here, 0.0150800. Okay, how many significant figures does that have? Get it so you guys can see that. Okay, so how many significant figures does that have? Leading zeros like this are never significant, so those are not significant. Captive zeros are always significant, so that is significant. Trailing zeros are significant if there's a decimal. Well, there's a decimal. So these are not significant, but these are. So this would have 1, 2, 3, 4, 5, 6. This would have 6 significant figures. And then, like I said, let's say we have 200 like this and 200 like this. And of course, everybody in the world would say those are the same numbers. Yes, they're right. But in terms of significant figures, trailing zeros are significant only if there's a decimal. So this would have 1 significant figure. This would have 3, because those zeros are now considered significant because the decimal place makes those significant. Okay, so in counting significant figures, then in calculation. So let's say that we have 4.56 times 1.4. So remember what I said, if we multiply or divide, how we round is based off the number with the fewest sig figs, this is what we're going to do most of the time. So here, if I have, this has 3 sig figs, this has 2. So I'm going to round to 2 sig figs. So I have 6.38, but that has 3 significant figures. So I should go to 2 sig figs, so it should be 6.4. And this will be important throughout our class, that we round to the right number of significant figures. Okay, and the same thing happens if we divide. So let's say that we have 2,432 divided by 61. So I'm just going to do that on my calculator here. So again, when we multiply or divide, the rule's the same. Whatever number has the fewest sig figs, that determines how many sig figs I round to. So if I do this, I get 39.86885246. Well, this number has 4 sig figs. This number has 2, so I should round to 2, which means I'm going to round here, and the 8 tells me to round up. So what I would have to 2 sig figs is 40. Now, when I add or subtract, it's a different rule. So let's say that I have this. Now, instead of counting up the significant figures, what I do here is I look at the decimal place. So if I do this here, again, this has 4 sig figs, this has 3, this has 4. But when I add or subtract, it is not based off sig figs. There we go. You guys can see that. It is based on the decimal place. So whatever number has the fewest decimal places. So this comes out, I think, to 31.123, but my sig figs are wrong. This goes to the 100th, this goes to the 10th, this goes to the 1000th. So I should go to the 10th. So I get 31.1 would be the correct reading there. Okay, and then one other problem that I have is what happens if they have both either multiplication and division or addition and subtraction. And what I call this is order of operation. So I have both going on. So there's a mix. So I've got, say, 8.925 minus 8.90 over 8.925. Okay. So what I'm going to do first, order of operations, is I'm going to do the addition and subtraction first before I do the multiplication and division. That's the way we're going to do it in chemistry. So I'm going to do addition and subtraction first before I do the multiplication and division. So here, if I do this, what I'm going to get is point, and then I'm going to make this times 100. So this is times 100. So what I get here is I get 0.03, like doing that first, divided by 8.925. Okay, and then whoops, times 100. And so what I'm going to get is 0.025. And then because this, after doing this, when I rounded this, again, this, when I did the subtraction, it was based off the fewest decimal places. And so I would have went to the 100th. And since that has 1 sig fig, I would want 1 sig fig. So I get, whoops, I get 0.025 times 100. So what I actually, I'm sorry, I didn't write this out right. It's 0.33613, which again, the 1 sig fig would be there. And one thing is, we're doing these in class. I really highly recommend you guys to go back and to do these problems that I am doing in class. And obviously, this is review. So guys, I'm going to go ahead and stop there. So that is where we're going to pick up next week. I'm doing kind of a trial run here, and hopefully this is working out, and we can touch base on Monday and Tuesday. So hopefully you have a good weekend, and I will look forward to seeing you Monday or Tuesday. Bye.